Good morning.
Shall I start the session, sir?
Yeah, sure, you can.
Good morning to all participants, speakers, and faculties. We are honored to have Dr. Sanjog Rawat, sir, from Central University of Rajasthan for this session. First, let me introduce to Dr. Rawat, sir. Dr. Sanjog Rawat received his BTech degree in Electronics and Communication Engineering from Visvesvaraya Technological University. M.Tech degree in Microwave Engineering from Rajiv Gandhi Pratyogiki Vishwavidyalaya, Bhopal, and PhD degree in Planar Antenna from Electronics and Communication Engineering Department, MNIT Jaipur. He is an associate professor and head at the Department of Electronics and Communication Engineering in Central University of Rajasthan. He has authored and co-authored more than 100 peer-reviewed international journals and conference papers. His research area include the microwave engineering, planar antennas, reconfigurable RF printed circuit, microwave and millimeter wave technology. Once again, we welcome you, sir, and thank you so much for accepting our invitation. Over to you, sir.
Thank you. Thank you so much. Very good morning to faculty members, organizers, participants of this workshop. So let me just share my screen. Is the screen visible? Okay, so I'll be talking
Yes, sir, it is visible.
about wearable devices. Okay, thank you. So my topic would be wearable devices. In between, I'll be talking a little about antenna also, and where do we use antennas in these wearable devices. So again, good morning to all of you. Today, we are going to discuss some of the potential breakthroughs and technologies which has recently, or I would say cutting edge technologies, which has recently happened in the case of wearable devices with respect to our healthcare and communication. So we all know that we have been surrounded by devices, and these versatile gadgets which we are surrounded of, they have demonstrated a lot of potential and transforming the landscape of today's healthcare, and it is also offering us unparalleled convenience, accessibility, and accuracy in the health monitoring. Apart from health monitoring, they have been able to provide, the one of the potential requirement for health monitoring is that there has to be a seamless communications between the patient and healthcare professional, so which is beyond the geographical boundaries. So in this particular talk, I'll be talking about some of those applications and how it has transformed the things. Is the overview of wearable devices, followed by applications in healthcare, then wearable which are being used for drug delivery, which are being used for energy harvesting, and wearables which are being used for augmented reality and virtual reality. So let me first start with wearables. So what are these wearables? See, these are nothing but a diverse range of electronic gadgets which
Sorry to
can be.
interrupt you, sir. Sorry to interrupt you, sir. Your slides are
They
not
have
moving.
there has been a very, very impressive growth in the popularity of these devices, and the primary
Hello.
reasons for that could be this portability, its ability to collect and transmit data in real time,
Sir, your
and
slides are not
they have
moving.
become actually an what I would say is indispensable tool for health tracking, even for
Hello.
disease management,
Sir, sorry to
for
interrupt
wellness
you.
promotion, and the if you we take an example of these devices, we all used to have smart watches which are equipped with fitness tracking features. Then we have got activity monitors that could be now for particularly for diabetes. You'll see a lot of advertisement where you'll find medical grade wearable patches which would provide continuous monitoring. And nowadays, even some smart clothing has also come up, which we'll be talking about with embedded sensors. So, if you look at the applications, in particularly the applications of wearable devices, so these applications of wearable devices, if I talk about healthcare, it is actually what I say is multifaceted because it is addressing various aspects of individual health and well. So, as I already mentioned at the beginning itself, that one of the most significant role that we are seeing nowadays is the use of wearable devices in healthcare, and in particularly, it is health monitoring. So, how do we do that? We are using, we are dependent on the sensors. When we have got advanced algorithms, and these devices actually can accurately track our vital signs such as heart rate, blood pressure, respiratory rate, body temperature, and and they can provide the users with the real-time insight. In this way, these devices are actually invaluable in the chronic disease management. So, if I talk about individuals which are having conditions like, say, diabetes, hypertension, any cardiovascular disease, say, asthma. So,
Sorry to
if
interrupt you, sir.
these, yes,
Sir, your screen is not, sir, your slides are not moving, sir.
which slide is currently being shown? Is it the IoT enabled sensor system?
Sir, it's the title slide which is currently being shown. And sir, it also
Okay,
that is not full screen.
I have made it full screen. Let me share it again.
Okay, sir, please.
I'll do it again. So, is it changing or not?
Now it's changing.
Okay. So, I was just giving an introduction about the wearable devices.
Sir, full screen.
That
Can you
what
do
are
the full
wearable
screen,
devices?
please?
Just a minute. Now is it full screen?
I think it will become maybe internet issue, sir. No problem, sir. You can continue. Right now, it's not full screen.
Okay. But I have from my side, I've made it full screen. Uh,
So maybe after few
Even the slides
seconds,
are
it
not
will
changing.
come.
Okay. So the slides are
Now we are
changing.
on the
Is it
slide wearable
the
device.
okay? Okay. So let me change the next one. Now IoT enabled sensor system. Is it
No,
showing?
sir.
No.
No, sir.
So that means the slides are not changing. And when I now is it?
Yes, sir. Now we are able to see the IoT slide.
But when I actually, the problem that is happening, I don't know why, is when I make it full screen, the slides are not changing. And when I
Okay,
make
okay.
it this compatibility mode, it is changing.
No problem, sir. We can
Okay,
study in
so
compatible.
okay, so thank you,
Thank you very
and
much.
apologies for this inconvenience.
Thank you, sir. Thank you.
So the applications which I was talking about was primarily for healthcare, and as I had mentioned that for chronic disease, say it is any cardiovascular disease, even asthma, diabetes, or say issues related to kidney. So these variable have the ability to detect, deliver timely alerts. It can enhance our self management, and it can even reduce the burden of the hospital visits. So that is what primarily these are meant for, so that we can have a what I say is the preventive health practices, and we can have a healthy lifestyle choices. So there are some, I mean, additional features also, say step counting, say sleep tracking, even stress managements. So it is actually meant for improving our overall well-being. That is what it is meant for, these advices. So if you look at this, so in this particular slides, you see that there is a patch. Obviously, it is a patch antenna, the patch sort of structure. Then there is an implant in the head. Then there is a smartwatch. So all these data is, I mean, getting collected, and it is going to through internet. It is going to a server, and it also is getting saved at the medical server. It goes to even professionals. It goes to even the family member. So what are the advantages of this sort of IoT enabled sensor system? It can have preventive medicine, you can have diagnostics, you can have prognostics, you can have therapy. All those things could happen. So like I mentioned about one of the example which I'll be discussing also in the next slide, that there is a very lightweight, comfortable bio shirts. So let me show you. So this is a bioshack which contains a respiration sensor, and the fabric actually has electrode, so that you can wirelessly record both respirations and ECG. And I mean, the subject and the person has a freedom. He or she can move freely, and even perform the task in short or long-term studies in the lab or even in the real world. So as I mentioned that this shirt actually connects to a wireless respiration and ECG transmitter, which is placed in a small pocket, could be at the front. This is the one, and it can, I mean, there are no electrodes, no gel or wires which are being used here, and it can transmit actually the data, either a standalone smart center, or with the, if there is a matching receiver module. So it could do that. So that is, you can see that that is the one of the example of a bio shirt where we can use these things for for collecting the vital information, which is nothing but that will improve our self medical management, and it can reduce even the hospital visits. Now let me show you another imaging system which actually measures the oxygen level and that changes what you call as the prefrontal cortex of human subject. And each system actually provides real-time monitoring of tissues, uh, what do you say, the oxygenation of the brain, as the subject is the person, he or she may take test, perform tasks, and actually this information will allow the researchers to assess the brain functions quantitatively, like the attention, the memory, the problem solving, the planning, and the individuals, they can perform their cognitive tasks. So this device actually uh, provides even the information regarding the change in hemoglobin levels, and that can be even calculated by there's a law which is called as the modified Pierre-Lambert law. So one example, as you can see that there is the person is actually wearing the IR, what do you say, sensor. This sensor actually has an IR light source, and, and there is a detectors which are mounted on this flexible band, which you can see on the forehead. So this forehead actually it detects again the, as I mentioned already, the oxygen levels which are there in the prefrontal cortex, and provides the real-time values for oxyhemoglobin and deoxygenated hemoglobin. So it gives you real-time information about the changes in the oxygen level as the person performs the different tasks. So this is one example. You can see that it is actually connected to a laptop which has got a data acquisition, analysis, and display. And this I had already mentioned that this is a sensor which has a IR light source, and the flexible bends has got the detectors, and there is a cable connected to it. This is actually the transmitter part. So this box actually transmits, and it is being received by the user device or laptop, whatever you call it. So this is how this works, and this is a basic sort of information which is given, that when a light source and there's a detector interacts, the change in the behavior is being recorded by the detector. So this is something which is being used to record the heel and toe strike, I would say, as the subject box. So the heel and toe strike is actually recorded on two analog channels. So one channel actually records the heel strike, and other records the what do you say as the toe strikes. So these strikes are actually indicated by deflections which are there on the graph, and you can see here two this sort of what I say bands. So these are nothing but the force sensitive resistors which are attached to the sole of a shoe, and they're being used. It is using two transducers also to record from both the feet. So as we know that, and the question arises why these all things are required. So we know that the walking is something which is a central activity of our daily life. There is a there has been a lot of demand nowadays, even for the gait analysis. What is mean by gait? It is not GAT, it's GAIT gait. So it is actually the way to assess the dynamic posture and coordination during the movement. So, as I already mentioned, that walking is something which is our daily activity, and there has been a lot of demands to have a gait assessment because it plays a very important role. So, for that we use what you call as variable inertial measurement units. They are being called as IMUs. So these IMUs actually have the potential to enable a non-restrictive and accurate gait assessment in our daily life. So it is actually governed by a set of algorithms that uses the measurements of the two foot-worn IMUs, and they actually gives you the what do you say, the clinical gait assessment, and these are actually divided into 5 gait phases. Uh, this is I mean, each side has got the stride length, say the walking speed. All those information is actually provided by this. So by these three of the things I've just mentioned, what are we trying to do? So all this information is actually we are trying to make what the term became very popular during the COVID times, which is known as the remote patient monitoring. So this remote patient monitoring has actually emerged as a transformative approach. This has emerged as a transformative approach to the healthcare. So particularly in, like we have already seen in the COVID, to manage actually these chronic disease, the post acute care, these example and few more we'll be discussing later on. They are actually playing a very important role in enabling the remote patient monitoring by continuously collecting and transmitting the patient's data to the healthcare providers. So this would help the healthcare professionals to actually remotely monitor the patient's health status, the treatment progress. If it is undergoing any treatment, then you can have early interventions in case of any deterioration, and that obviously would reduce the hospital admissions and even prevent the complications. So actually this remote patient monitoring, it provides what? It provides a patient with a sense of ownership, and it also gives you a control over the health, promoting the what do you say, the self management and even the patient engagement. So moving ahead, we have got this, which is a drug delivery. So let me give you a brief background about this. This comes under the telemedicine and even the communication. So this is considered to be an advancement in the case of uh, wearable technology. So we know that we use smart watches, wearable cameras, which can help us in video consultations, and even the operations, surgeries are being performed remotely. So it has got a not only the remote diagnostic capabilities, it can even make a virtual doctor-patient interactions, and I mean the patients which are particularly in the remote areas, they can have the what do you say, that the improving healthcare accessibility, and this would ultimately reduce the healthcare disparities. So basically, this telemedicine and communication would help the patients to communicate easily with their health concern. They can receive feedback. They can go for treatment plans, and they always stay informed about their health progress. So now, in this particular category, we have got one very important topic, which is called as the drug delivery. So this is something which is very important because as per the studies, a lot of paper also have been published in this area that the poor adherence to drug dosing schedule is actually responsible for nearly more than 50% of hospitalization cases. And in most of the cases, what happens is the patient actually fails to strict dosing schedules, and this is this is primarily because of the drug administration, or maybe could be the medical conditions of a patient like dementia. So uh, there is a term, or what do you say, the variable technology for drug delivery. It has actually created new opportunities for treating the patients which are actually needing the repeated and long-term medical attention. So diabetes, or say ocular disorders, wound healing. So they are actually born on the body surface, and they have they can self-administer the drug delivery, which I mean for that you can see there are micro needle skin patches. Okay, then we have got there are even now what do you say, drug eluting contact lenses. Then we have got there is a term which is called as pharmaceutical jewelry. Then we may have drug loaded self care textiles, which you can see that there's an ocular ring. So they are, I mean, the wearables. They are you can worn on the body, and these are actually on the right are the ones which are implantable, so which you can implant inside the body, and they have the capability to uh, deliver the drug. So this is something which is a lot of work has been going on in this particular area. A lot of people are working in the cases of drug delivery. They're using nanotechnology, the the microneedles. They all are actually meant for the drug delivery purpose only. So in this case, we use a very miniaturized and smart nano devices which can be integrated into the wearable devices for a controlled, or what do you say, a targeted drug release. So this sort of technology actually it is quite promising, and it could be possible only because of the advancement in the case of nanotechnology, and when the nanotechnology and wearable they converge to deliver a drug delivery. As you can see on the left, we have got a wearable devices, and on the right, we've got a implantable devices, which is inside the body, and these are on the body. Now, moving ahead, this particular slide is something which is related to uh, the say energy harvesting or what do you say self-powered variables. So the basis of that is like we humans, we have got a lot of available energy from our mechanical movement, like running, jumping, walking, anything that we do. And there are devices which are electromagnetic or piezoelectric and even the triboelectric devices that can harvest the energy, and they can even convert our body mechanical energy into electricity, which could be used to power these wearable and implantable electronics. So this would really help us for a very high this and I mean these if you have a self-powered wearable devices that would ultimately reduce not only reduce the size, it would also reduce the cost of the devices. So in this particular slide, you see there is a term which is called as BISS. So this BISS is actually inspired by the full form of that is Body Integrated Self-Powered System. So this term was actually proposed in, by one of the researchers, Ho Jing Shi, and it was in the year 2019, and it is being used nowadays in case of energy harvesting for the self-powered variables. So what is happening actually? The biomechanical energy of the moving human body can be actually harvested through a piece of electrode which is attached to our skin. So the basic principle of this BIS uh, is actually inspired by the comprehensive effect of what do you say in this particular case the comprehensive effect of electrification between our soul and the floor, and that leads to electrification of the human body. So advantage of these energy harvesting technologies are they are actually innovative. As you can see, uh, they have a they are offering a very sustainable approach to uh, to powering the wearable devices, and they actually can harness and generate power from the diverse, diverse sources. Not only the movement, there could be the body heat, any ambient light. So they are transforming our wearable devices into what you say as the dependent or self-sustaining entities. So there is, I mean, it reduces actually what once you have the energy harvesting devices, it reduces the frequent battery replacements. It can even enhance our experience and also extends the operational life of variables. So that is the advantage of these self-powered variables. So here you can see that one of the variables is this is the band and this is the glass, and for this I've already mentioned there's a floor, so it is actually taking energy from our foot movement and when it is hitting the floor. So next we are going to talk about the use of wearables in case of augmented reality and virtual reality. So I mean a lot of uh, things have come up, particularly in the case of augmented reality, virtual reality, a lot of courses have come up. Various institutions have already come up with the AR VR labs. So basically, in this, we are integrating the wearable devices with the augmented reality and virtual reality to give you what we say as the immersive experience, which is which actually takes make you feel like it is happening in reality. So you can see that we have got now the augmented reality glasses. You say there is a term Oculus, which has come up now for metaverse. There is a lot of games, many things that come up. So I mean, the uses are diverse, including education, even entertainment, and even for productivity. So they're actually playing a very vital role, this AR/VR. And what is the basics of this AR/VR? So the basis is that we as a human, we have got a sensory system. So our human beings are having a sensory system which actually assists the humans to adopt things, to survive in difficult and even the what do you say, the extreme conditions. So one of uh, the important ones in this human sensory system is we say that the ability of the human being to sense the temperature is one of the critical attributes that really help to perceive and interact with the external environment. So this the term which has been used for the human body to sense temperature, this is called as we call it as thermoception. So what is thermoception? Thermoception is nothing but ability to perceive temperature or the sensation of cold or warm. This actually helps for any user to perceive the things. So thermoception is not uh, it is also what do you say, influenced by other sensory perceptions like visuals, and even humans, as a humans, we actually associate colors to a different temperature. So like a red color we generally use for a warm sensation, and the blue color is used for generally the cold sensation. So that's the human association to different temperature with respect to the color. So why this is so important? Because the this temperature sensation uh, actually help us in better identification of the things. So through this, I mean, how do we actually do these thermal sensations onto what do you say, virtual objects, or through augmented simulation? Is it possible for humans to or to feel the thermal sensation? So for that, there is a term which is called as thermal haptic. So this term has been experienced or used by various commercial technologies, and even they are being used for if you want to experience the scuba diving using augmented reality. So this could be performed, this could be experienced by utilizing a set of devices which is called as the Peltier devices and even the motion platforms. So what they do actually, they create the sensation of heating and cooling, and these uh, thermal haptics will make you feel like you are feeling a realistic wind sensation. Okay, so you will feel that actually it is happening in augmented reality, but you will feel that it is happening, or you can feel it that it is happening actually. So a lot of work has been going on in the case of thermal haptics, so that the subject or the user can can feel like a real-time experience. And I mean, this has recently come up a lot. So for that, we to have this what you call as thermal haptic or thermo sensing, you would require a thermo-resistive sensors which are to be used. Along with this, the pyro, a lot of design a thermal haptics and a way that it can stimulate the thermal sensation. So here there are, I've shown some on the right and some where thermal haptics are nothing but electrical plus thermal energy. Thermosensors are converting the thermal to electrical energy. So these all, I mean, things are available that could really help to feel or to make the AR/VR more realistic. Now, as we have talked about some of the examples, in case of, particularly in the case of wearable, situation is ethical considerations and the future of, I mean, wearable devices that we should look upon. What are we expecting in the future? So the considerations that we should look for is, the first thing is safeguarding our data privacy, then looking for security, and there is, I mean, a lot of collaborative work that is required between academia, industry, policymakers, and healthcare professionals, so that we can establish ethical guidelines, and there's no framework, so regulatory framework that would also preserve the user rights. So innovation, along with that, we have to look into the other side also, that it should also preserve the user right. Now, we have seen so many things so far, but there are a lot of challenges also in the field of wearables. So what are these challenges? Data accuracy is a very, very critical concern. So since we are entirely dependent on the data, any accuracies in the health monitoring data, it actually leads to incorrect medical decisions. So that is something very, very important. Second is the battery life. The battery life is another challenge, because as long as the battery duration would improve user experience and would be better, and there is no it will reduce the frequent recharging needs. Like in case of a pacemaker, there is a duration after which you have to the minor surgery have to be performed and the battery needs to be changed. So that is something that one should give due consideration in case of the. So apart from this, what is the future scope? As I've already mentioned, a lot of work needs to be done on the security and the uh, on the security as well as also on the ethical considerations. So now in the future, or already it is in place now, we may see that there is a wearable AI assistants which are available. So these wearable AI assistants, they might have the potential of the emotional intelligence. Uh, these they may also have the ability to respond to users' emotions. So providing the tailored strategies, uh, even the emotional coaching. So this is these assistants will be will actually may provide the more emotional connection between the users. Then we may have brain computer interface for say cognitive enhancement. So this brain computer interface, uh, it actually is relatively new, and it holds actually the potential to what do you say, augment the cognitive capabilities. It will even learning and even solving. So this is something which actually provides assistance of the individuals with possible the harmony between the human and machine collaborations. So this is something that we are expecting uh, in the future. Even the wearable devices uh, could be they can extend uh, beyond personal health. We can even use them for environmental monitoring and sustainability. So we can design wearable sensors. It's already in place now for detecting the pollutants, uh, for measuring the air quality, AQI that we do, and even monitoring the environmental other environmental parameters that would help in environmental conservation efforts. So this, I mean, convergence of variable and sustainability, it could lead to help in the environmental monitoring. Uh, Another aspect could be, so this variables can even be used for human performance enhancement. So how do we do it? So, like in sports, if I give you an example, uh, an athlete may be helped to optimize their training routines, to monitor their performance metrics, and this could actually prevent injuries. Similarly, if I take an example of a workplace, it can actually enhance productivity. It can even reduce stress, or can track any cognitive fatigue if anybody is going through. And so this can be even used for variables, can be used for even our human performance enhancement. This can really help. But as I already mentioned, that data security and privacy is something which is a major concern in case of the variable, because the wearable devices are actually handling a very sensitive health data. So we must ensure the data security and privacy, and for that there should be any even the healthcare organizations or the device manufacturers, they could join hand together, and they must implement something which is a very robust sort of data encryption and security protocols, I would say, that would safeguard the patient's uh, confidential information. Because if I take an example of like we were talking about smart fabrics, I just had shown you that smart fabrics are being used, and there is a term which is called as e-textile, which so this is nothing but the fabrics which are embedded with sensors and microelectronics. So, and they are used as uh, everyday apparels we can use. So, I mean, they would help us in various vital signs, posture. They can even help us with environmental factors like what is the air quality, how much is the UV exposure that is there, and I mean we can have these e-textiles which could be used for any industry, let it be a fashion, sports, even military. Then one of the aspects which I had mentioned over here is uh, the neural interface variables. So what are interface variables? So it is again comes under the category of the human computer interaction, I would say. So these variable actually that helps the direct communication between the human brain and the external technologies. So it allows for the emergence of what do you say as the brain controlled devices. So we may think of a future where wearable devices can be simply operated by thought, or a sensory feedback can directly be delivered to the brain through neural interface variables. So this would really help in the individuals with disabilities. This will help in enhancing their uh, cognitive functions, and it will help in the new dimensions of human connectivity. So so far talked about the various kind of variables which are being used, and they all are actually using antennas, because antennas are one of the very vital component in the field of these all variables, this which I just shown you. because for communication we are entirely dependent on antennas, other sensors, other communication devices. So we are primarily dependent on these. So they all the technologies that I have shown you. This you can see that there is a patch which is being used, and this this comes under the antenna only. Here also there is a sensor pad which has to communicate, and then there is a wireless box. Again, antenna is being used here for communicating with this. So I mean, any device which I think it has to, for communication purpose, we are entirely dependent on antennas and how do they work. So now let me give you some information related to the recent development in the field of antennas. So let me take you to another slide. Okay, let me just show you some other advancements which are being taking place, and then we'll move on to the antenna.
Hello. Am I audible, sir?
Am I audible?
Yes,
Yes,
sir.
sir, you are audible.
Okay. I think because of technical glitch, I had to
Yeah, yeah.
rejoin it. Let me
Yeah.
again share it. Is the slide visible?
Yes, sir, it's visible.
Okay. Thank you. So these were some of the other examples which I wanted to show you, that there is a smart jacket, then there is smart shoes, then there is a shirt which is having a variable piano. Moving further, you will see that there is a standalone devices. So this sort of devices can be used for sugar measurement, other information. So there is a smartphone integration with the device. This is the traceable category. These are the accessible, the bands. Then I've already mentioned that the smart lenses through which you can have drug delivery. Or these are the skin attachable or the transparent patches, and these are the implants which are inside, which can be placed inside. So these are, I mean, the bands that we usually see, which can use information like your heart rate. Even now, some of the bands, they have been able to give you your sugar level also. Recently, I was going through an article where sweat has been used to could be used for your sugar level measurement. So these are the patches. You can see that there's a S patch. It was produced, manufactured by Samsung. So here you can see that these are the various ways you can take the sample. I have mentioned just a few. So the samples could be taken from your activity, from your screen, from the emotion, I mean, your odor, your breath, your hydration, your sweat, your wound fluid. So all these information can be used for providing the parameters like ECG, EMG, skin temperature, skin strain, pulse rate, blood pressure, blood oximetry, and these are the various sensors. So there is a biopotential electrode, there is a temperature sensor, there is a strain sensor, there's a pressure sensor, there's a humidity sensor, and there's a biosensors. So you can see that there are these many ways through which we can extract the information, and those datas are to be collected in the form of electrical signals. So even the sweat, even the odor, even the breath, even the your uh, just by face recognition, emotions, even your skin, your activity, these all actually gives a very vital amount of data, and that could really help in the proactive medication and anything that needs to be done. It will reduce the complications and the hospitalization or hospital revisits. So now let me show you some of the antennas.
और इसे करवा को तो अलग से स्पीकर फोन दे दो आपको और भी चल रहा है
So I hope this slide is visible, which is talking about the controlled drug delivery system. So there is an endoscope capsule. हाँ. Sure, sure. So you can see that the controlled drug delivery system, which is an endoscopic capsule. Now in this, you will see that along with various I mean components, one important component is an antenna. So there's a battery, there is an the electronic components, there is a micro reservoir, there is a micro needle, then there is a drug. So this capsule is it is a swallowable capsule, and through external transmitter we can collect the information. When it reaches the target infected area, then the drug could be delivered. So the communication is, I mean, one of the vital component in the communication is this particular antenna that will communicate with the external device, so that how much amount of drug is to be delivered, when the drug is to be delivered, this could be done. So let me show you one more example. Okay, so sorry I couldn't find that. I had a couple of more antennas. So now lastly I'll be talking about the, now we've seen that various applications of wearable devices, and as I've already mentioned, that antenna plays a very vital component in the field of wearable devices. So just a brief information about antenna, since this workshop is already about antenna, so you must be knowing all those things. So what are the design considerations? These are the some of the broad design considerations, but actually the design considerations of an antenna would entirely depend on for what particular applications you are using an antenna. So radiation pattern, whether we are looking for a particular you want to cover, like in case of our mobile phones, we are only we want directional patterns and particular directional patterns. Similarly, what is the bend of operation, what is the position of an antenna. Position of an antenna also plays a very important role, because we in wearable devices, since they are very small, the antenna should occupy the minimum space. It should be conformable to the surface. So all those things we have to give due consideration. Then what is the beam width, what for what particular applications generally we prefer to go for narrow beam widths only in this case. Then if there is a side lobe, what is the side lobe levels. The most important thing is the size of antenna. What size of antenna, it again depends on where we are placing. So if I am using an antenna in a wristwatch, it has to be a very very small size. But if I am using an antenna for a transmitter, then we can afford to have a bigger size. Nowadays there are uh, transparent antennas which are also being available, that can be placed on your window glasses, then can be embedded actually inside the window glasses, so that they are not visible to you, and they are
But your voice is not coming.
Am I audible?
Yes, sir.
I'm sorry, there was a power cut.
Okay.
So I'm done with my presentation. I'm open to questions if you have any.
Thank you, sir, for the lecture. There are some queries, sir, in the chat box.
Okay, let me have a look.
Can I read?
No, I'll go through one by one and I'll answer.
Hello.
Hello. System is- I could see few of them. So
So the first,
one of the query is that in case of disabled people, which type of variable are currently available? Is it possible to control their emotions and how? I think I had already mentioned about it that there are neural interface variables which are available and that can to some extent that can give you the information of that if a person uh, they are actually the brain control variables. So if a thought comes of a it is meant actually for disabled people only. Next okay, which material substrate or radiator is safe for capsule antenna in terahertz frequency range in the name is I think PTFE, which could be used. There are many more, but PTFE is relatively cheap, which could be used for antennas, particularly in working in terahertz range. Then yeah, uh, is there any specific technique to improve the antenna performance under the bending analysis? Actually, nowadays we are I mean, many of the work has been going on where we are looking for the flexible antennas so that the bending will not actually have any impact on the performance. So many materials are available already. The only issues that we are facing is particularly in case of flexible antennas is that those materials if I mean if you want a very flexible material, then it is adversely affecting some of other performance. So there is a work already going on and there are some flexible material already available in the market which will not affect much on the antenna performance and even on bending. And which book is being used for IoT based antenna? Recently Artec publication has come up a book in 2023 they came up, and I think in 2024 also there is a book which is on IoT antennas and its applications in IoT. How can we use AI and ML for see AI ML's techniques can be used for optimization of antenna parameters. The basic problems that we face while designing an antenna is when you try to increase one of the parameters, say bandwidth, then you end up with reducing the gain. So these techniques could be used to optimize the parameters depending on a particular applications. So although the EM simulation tools, They have got optimization, but we can always use AI and ML to optimize the performance of an antenna. Then there is another question that can we calculate S11 and S21?
So actually, these questions are the previous sessions.
Okay. So I think whatever questions were there, I have answered.
Yeah. Okay. Thank you so much, sir, for delivering a special talk in this RTP and taking all the participants' doubt they seriously. And we truly appreciate your time, effort, and willingness to share your expertise with us on topic wearable antenna and some IoT.
Thank you so much. Thanks for the invitation, and
Thank you, sir. Thank you for coming.
okay. Thank you. Thank you to all the audience. Thank you so much.
Participants, this session concludes here. We will now take a lunch break and our next session will be at 4 p.m. So kindly join at 3:45 p.m. Thank you.